over.
Yeah, about that. I'm struggling with my audio permissions. Yeah, so I similarly came across Supabase on like Hacker News, and the first time I saw it, I had a couple of existing open source projects that were attempting to solve similar problems in a amateurish way, specifically in the Python ecosystem. So things like making migrations easier and reflecting APIs, and sort of had a philosophy all the while of abusing Postgres to do things that it can do, but is not necessarily like the first thing that jumps to mind for, like task managing, pub sub queues, and things like that. So the sort of area that Supabase was operating in was definitely one that I had a strong interest in, and drew me to Supabase specifically over something similar is the openness. So that all being completely around open source, and then as someone who's very into Postgres, this admin, getting full access to the Postgres database is fairly unique Supabase versus any other hosted offering. So that was definitely a big plus and an interest for me. It opens up a lot more possibilities, some of which we'll talk about today.
Brilliant. Thanks, Ollie. And then we do have Ant and Paul in here as well. You might know them as the co-founders of Supabase. Do you want to do really quick why Supabase for you guys?
Yeah, definitely. Actually, first, I'd love to just mention, like, with both of these guys, the stories about how they came on board are quite fun because I think Wembo mentioned he was already contributing to Supabase, as a community member first, specifically to the real-time code base. And it was just one of these instances where he was just adding so much value to the repo that we basically had no choice but to hire him. Which is just one of the awesome things about open source, I think, and like sort of building in public from the start, is you just get these awesome moments of like, wow, like everyone's aligned. We already know that like Wembo is an awesome engineer. Like it was just a total no brainer. And then for Ollie was funny because when we got Ollie's CV, as he said, he'd already like tried to solve similar problems with Python, and it was this Python and Postgres combination which kind of caught our eye because we were thinking, well, we could bring Ollie in and he could like lead the charge on building a lot of tooling and like demos for Python with Supabase, for data science use cases and machine learning and things like this. And then when we interviewed him, he asked us, well, what are the most difficult problems at Supabase? And one of the hardest problems at the time was security for real time. And basically, like in the interview, Ollie started just whipping out solutions. As he said, he's kind of a Postgres hacker, and just basically started coming up with solutions to like our most difficult problem as a company. So it was just another instance of, well, this is kind of a really easy decision to make to welcome Ollie to the team. Yeah, and just for me, for people who weren't here yesterday, I'm the CTO and one of the co-founders. And Realtime was one of the first things that Koppel, who is the other co-founder, showed to me about the project. So he built an early version, and he said, with this real-time API on top of Postgres, along with the Postgres CRUD API, like we kind of have a basic version of open source Firebase, and that for me was super exciting.
Yeah, and for me, I think we'll get into this within this conversation because it's all about real time. But basically, as Ant said, this is kind of the genesis of Supabase itself. The real time server was actually built in my previous startup, and we used it to listen to changes inside the Postgres database and specifically to change to migrate away from Firebase. Actually, I needed it within our Postgres database. So really, this is how Supabase came into being, this server itself. So it's about 2 years old. We'll be going into a lot of the implementation in this chat, but yeah, we've had a lot of changes along the way, and this today actually marks a huge milestone that we're achieving with real-time row levels security. So yeah, really excited to dig into a few of the topics.
Brilliant. Now, before we jump in, we have a way for you to ask the team questions. So if you have any questions kind of throughout this about Supabase, about real-time, any of that good stuff, you can tweet at Supabase and just include the hashtag Super Launch Week. So that's SUPA Launch Week. And then we can pick it up right here and answer it live. Brilliant. So yeah, get your questions over to us. And in the meantime, yeah, maybe first of all, tell us about the real-time API and how does it actually work? And maybe Koppel, you can kick us off with maybe some history.
Yeah, actually, so maybe I can give the early stuff, and Wimbo can correct me on any mistakes that I make, seeing as he's done most of the work these days. So when I first started, of course, if you've used Firebase in the past, maybe you haven't, but it has this really cool feature where you can listen to any change inside the Firebase database. So if you push an update to the database, then on any other client, maybe a website or an app, you can receive those changes just by subscribing to them kind of over a WebSocket. And we were using that in my previous company, and we hit some limits, some scaling limits. So I was looking at ways of migrating away. So we were using a Postgres database, and I did a few naive things. One of them was using the inbuilt sort of pub sub within Postgres. There's got the Postgres has this sort of notify system, and the way that works is you can attach a server to the database and you can send out a notification. But I didn't realize at the time that there's a limitation even on Postgres, surprisingly, that the notify can only send 8,000 bytes. And I was using it for a chat system. And sure enough, there were some messages that were larger than 8,000 bytes, and the system started failing silently. So I looked at a few ways to change this, and one of the leading ways, well, one of the things I was using at the time was Elixir, and in particular the Phoenix framework. Very nice if you're looking at getting into Elixir, and it kind of handles a lot of the WebSocket work that I needed. So scaling the real time, the client subscriptions. But what it didn't have was this listening to the Postgres database. So I found a library. We do a shout out to it inside the real-time server itself, that it can attach to actually Postgres's replication stream. So the real-time server, the Elixir server, looks to Postgres like another Postgres database, and it can send kind of replication changes. And then we convert those changes into JSON, and then we blast them out over WebSockets. So that's kind of the mechanism that led to real time. I think, Winbo, did I cover most of the stuff there, or there might be a few other things that I missed?
Yeah, that was absolutely brilliant. And I just wanted to add that real time before today would broadcast to all connected clients. And so today we're announcing real time security. And what that means is real time server will now poll for changes from the replication stream. And it's going to pass those changes on to a Postgres function that I'm sure Ali will talk about in a little bit. And what real time server is really responsible for is to get back an array of authorized users and then to officially broadcast to that array of authorized users the database changes. So yeah, everything that Paul said is absolutely correct. We've had to sort of change how we do things just to make sure that we adhere to the new row level security policies that many of our developers have in place. But yeah, that's essentially what real-time did, is doing, and will do in the future with real-time security. Yeah.
Nice. So, so with kind of the original real-time server, the row level security didn't work from the start. And I think you've kind of mentioned a little bit sort of the challenges with that, but I'd love to kind of dig a little bit more into, why was it so challenging to make that kind of row level security policy work for the real-time server? And, what did it actually take to kind of make it happen in the end? And yeah, maybe Couple, do you want to sort of kick off why it was challenging in the beginning and then hand over to Ollie for the integration details?
Yeah, so actually, the way I said that my initial implementation was naive, and probably I should have said that my second implementation was quite naive as well. Really, what I built was a change data capture server. So it captures all of the changes, and then it blasts them quite blindly out to anyone who's subscribed. But the difficulty of this is that um, that's very simple, and it's quite useful. But what you really need is that every single row or every single change in a database has a security model that is different. So some users can see a change and some users cannot. Um, and it really depends on the row and it depends on the user who is subscribed. Now, this is quite a complicated thing, and at the time, it was kind of a stateless server. So the Postgres database didn't know who was subscribed, only the real-time server, and also then the real-time server wouldn't know what are the Postgres row-level security rules. So there's two sort of very dumb servers talking to each other. So the challenge was trying to figure out how to make these two servers communicate very well with each other so that real-time would pass over who is subscribed and Postgres would pass over, well, which changes are those subscribed users allowed to see. And that's really where Ollie was the brains behind the operation.
Yeah, I can jump in there. So if we cut away all the real-time stuff, the lowest level thing that we're trying to achieve is getting existing row level security policies to apply to a logical replication stream. And in order to do that, the high level flow of what we needed to do was pretty clear, but inflexible. So we definitely knew we would need to make some form of data structure describing who is subscribed to which table available to this authorization engine, as well as access to that record stream of all records. And we want to make those raw records readable directly from Postgres from a secondary server or process. We tick those boxes, which could be achieved in several ways. I'll jump into the specific implementation. I'll just cover the flow first. For each wall record, we wanted to identify. So you first have to identify which table is the change coming from. Extracting the data from that record. So if it's an insert, you can imagine every field is going to be populated with the contents of the record that was just inserted. And then for each subscriber who is subscribed to that table, subject to their user-defined filters, we need to assume the identity of that subscriber, which in our context, or in the context of row-level security helper functions, means setting the same configuration that Postgres, the API server, sets that underpin the row-level security helper functions like auth UID and that sort of stuff, so that if someone has written that row-level security policies against those helper functions, they'll continue to work. Yeah, but we also want to, so when we're assuming the identity of each subscriber, we need to make sure that we're using the same role as the API server is. And once we have taken on identity by controlling the config in the transaction that the record is being processed in, you use the source table and the primary key information from the record that we're inspecting and query the table using the primary key data as each subscribed user to see if that record is visible to the user. If it is, append it to a list, and that gets returned to real-time. If they are not, then they're not included in that list, and the change will not be broadcast out to that user. So that's the high level view. The problems that you run into when you take that kind of approach is it tends to be pretty slow if you do a naive implementation. If you've only got one in Postgres to work with, then your concurrency limit is 1. You also don't really have great control, or it could be a very bad developer experience if they had to be strict about the number of changes that were being captured in an individual table, or the number of subscribers who can subscribe to it. So the only thing in this process that we have any control over, if we're trying to control speed, think about the total time taken to do this processing, is a number of records times number of subscribers times time it takes to check each subscriber. And we got one dial to turn, and that is how fast the auth check is. So that's where we put all of the time into trying to make it as fast as possible. So to that end, we ended up with a 100% SQL implementation. The first thought we had was to write this as a Postgres extension, like a C extension, for the implied performance speed up of C versus SQL. Turns out you can't do that because the row level security policies don't apply when you do queries directly from C. So it turned out to be easier to, or actually required to write this in SQL if we wanted to keep it all on the Postgres server. The implementation is a single function that we can pass the logical replication wall records through. So imagine just like stuff through a function, and that's appending the extra information that we care about. So like if a user is able to view a record, and keeping it all in SQL and as a single SQL function eliminates a lot of the overhead that a naive implementation polling each user using the process described from a secondary process would have. So specifically, network round trip times will just murder performance if you've got more than a handful of subscribers, because even if you're on the same machine, the connection overhead plus going across the network slows things down to the point where you're not going to be able to support more than say 100 subscribers to a table at a time and be able to realistically call yourself real time.
All right.
Yeah.
That is a lot of information to digest. So I think we'll also have a blog post written up about that, so we can link out to that if you kind of want to recap any of that information. But you were talking about kind of the performance piece a little bit, and we actually have a question from the community that we've pinned up there. And they are asking specifically about kind of how many concurrent connections can be supported. So I think that's the first question. And then in Firebase, we can subscribe to any kind of nested level, sort of individually. How would you handle that with Supabase Realtime?
Yeah, so the performance is going to be heavily dependent on the row level security policies that are associated with the table. For best case scenario, where your row level security following all the practices for performance, like not including any joins, where you're effectively just looking up something from transaction local config, and then there's an associated column table. That's definitely the best case. In that case, your first subscriber is going to be about 7 to 11 milliseconds of overhead. From there on, it doesn't continue linearly for each subscriber. So from 25 subscribers, more 15 milliseconds, 500 subscribers, 29 milliseconds. But that all is hidden because under the hood on the real-time side, the records are polled for every 100 milliseconds. So until we get to about 3,000 subscribers, in ideal case, you won't going to notice any differences really. You can go beyond that 3,000 subscribers, but that's when you can potentially have a delay of more than 100 milliseconds in how long it takes for the information to get out to your end users.
Gotcha. Okay. So, I mean, I guess theoretically it is sort of unlimited, but eventually there comes a turning point when usability or user experience is not really ideal anymore. So yeah, we'd love for y'all to stress test this. So if you build some real time apps, then let us know when it bogs down. And I think the other question was sort of the nested subscription. So I guess Firebase sort of supports kind of subscribing to nested level individually. How can we handle that scenario? I'm not entirely familiar with that use case myself. I think probably you've used Firebase kind of fairly extensively before. Any answer to that?
Yeah, so first of all, Postgres is Supabase is based on Postgres. So as a relational database, there's not too much nesting. You sort of build the joins themselves. I guess the sort of analogy here might be that you would build a view of your data and try to subscribe to that, which we don't support. But what we do support is subscribing to whole tables and then, or even the whole database itself. The whole, say, schema. And then the row level securities will be applied across the whole schema. So actually, it wouldn't matter as long as you have your row level security policies in place. You could essentially subscribe to, say, the public schema. You'll receive that change, and inside the change, we'll tell you, the change has the table, the schema, which row is updated. So you would use that information to, on the client side, essentially, insert it or update your view. So very similar end goal, but maybe with a different methodology.
Gotcha. Cool. So yeah, we mentioned a lot of information in there. We've pinned you the link to the blog post, so there's some more visuals in there that you can dig into to kind of recap this. And then also, yeah, for anyone who kind of dialed in recently and might be new to Supabase and the launch week, give us a little reaction, give us maybe a little peace sign here. Welcome to the party. So Supabase is the open source Firebase alternative. We're building kind of the features of Firebase, but using enterprise grade open source tools. And so, particularly focused on scalability with proven tools like Postgres and a lot of open source goodies on top of that. And yeah, really focused on kind of scalability, but at the same time, the developer experience for that. And today we have been adding row level security policies, a very powerful concept within Postgres, to our real-time engine. And that's what we're talking about right now. And if you have any questions for us, you can tweet them at us and we can answer them live. Just tweet at Supabase with the hashtag Super Launch Week. So that's SUPA Launch Week. And then we will pick them up there. Great. So yeah, maybe we've talked about sort of a lot of the performance behind this and the technology of building on Elixir and of course open source, so you can check out the code as well. Maybe you can outline a little bit sort of what's next. What is not yet implemented? Where are we taking this real-time API? Kind of what further iterations will be happening once we've kind of caught up on the sleep that we've lost during launch week. Wenbo, any insights to share there?
Yeah, I think you've already touched upon this, but I think performance is going to be really key, especially since real-time security has just been rolled out. And I think Ali has done a wonderful job tweaking the performance of getting the authorized users from the Postgres functions. And I think when it comes to real-time server, like I mentioned before, we're actually polling for the database changes. So I can definitely see us introducing smarter polling or even customized polling. Somewhere in the near future. And I think Paul mentioned this before when he answered a listener's question. This is something that a lot of members in the community have been asking for, which is like better filtering of database changes, just so that they can get exactly the changes that they're looking for. So that's something that we sort of want to discuss and improve upon. And yeah, something else to look forward to. But yeah, I think that's it for now. We just want to make sure that real-time security is again really secure and performant moving forward. So yeah.
Brilliant. And then, I mean, sort of everyone can, wrap their head around, what does real time mean? I guess the easiest example is, you're having a chat conversation with someone, or like a group chat, and you're really getting everyone's messages to everyone in real time, as if they were sort of in the same room chatting to each other. But I guess the chat use case, it's not the most creative one. It's an easy to understand one, but maybe just a question around the room. And also we have some fantastic guests here today that are also doing some cool real-time stuff, and so we can ask them as well. So that's Francesco and Ido from daily.dev. Thanks so much for joining us today. And maybe actually you can kick us off with kind of your real-time use case and how you're doing that. And then we can go around the room and sort of, have others chime in with some cool use cases. Should we do that?
Yeah, perfect. So thank you very much, first of all, for inviting us and for doing this awesome Twitter space. So I'll just start by introducing Daily Dev real quick, and then we'll jump to our real-time use case, if this works. So for those of you who don't know daily.dev, it's a browser extension and a web app that aggregate news from many different sources, and we pick only the latest and trendiest developer news around the web and put them in one feed personalized for you. And Supabase obviously is one of our favorite sources, and we've been seeing a lot of activity during this launch week on our platform, so this is awesome. And yeah, so our real-time use case is mainly to surface engagement that happens on the platform in real time. So this means upvotes. So while you are browsing the feed, we want to show you everything that is getting updated. So you see the upvotes moves in real time, and if someone's comment, you will see it as well in real time. We try, to create the same experience, the browsing experience of Twitter, where you browse your feed and scroll it, and you just see interactions everywhere. And actually, this is something that we built pretty late in the life cycle of our product. So, and I once heard like something about real updates, real-time updates, that if you don't think about it ahead of time and you take it like it's core part of your architecture, then you'll have a hard time introducing it. And it was definitely true for our product and the scale that we had at the time we introduced it. We had to do a lot of changes and a lot of hassle, especially in terms of the infrastructure that we used to make it work and make it scale. Like we have thousands of concurrent connections at any given time, so we had to take it into account. So this is roughly the introduction. If you want me to deep dive into some specifics, I would be happy to do it.
Yeah, I think would be nice to kind of hear a little bit how you're dealing with the real-time updates. Are you using push notifications at all? Or I think you mentioned you're using GraphQL subscriptions. Maybe if you can share a little bit there, would be nice for the audience.
Yeah, so exactly, we use GraphQL subscription. We use GraphQL for the query part and mutations for a long time. We're a big fan of this GraphQL. It it served us well so far. So just adding the GraphQL subscription was a low-hanging fruit for us. So we implemented it over WebSockets. And so we slowly started presenting more and more subscription. This is the official name, of WebSockets or channels, or however you used to call it in different platforms. So we introduced slowly more and more subscriptions. So the first one was for getting the upvotes and for getting the comments, and we use Redis behind the scenes to pub sub all these events through our cluster of servers. So every server can know that something happened. And once this happened, the server dispatches a message to all the clients that are connected to it. And all the clients can, get the update and refresh their UI or whatever they have to do. And the fact that I mentioned before we had to change the infrastructure is because we used to deploy our API on Cloud Run, which is a serverless solution by Google Cloud, which at the time did not support WebSockets. So we had to do a Kubernetes migration to some of our servers, and had to, introduce session affinity and all of this stuff that it's pretty complex in terms of scaling and like infrastructure work.
Wow, yeah. And if all of that sounds pretty scary to you and you're looking for a little bit of an easier solution, then you can use Supabase Realtime API. Sorry, shameless drop there, but no, thanks a lot for sharing that. That's really useful to know. And maybe last question for you. We've heard your real-time use case, but sort of, are you planning or are you using Supabase at all today? And if not, why not?
So actually, we've got to know Supabase pretty late in the life of our project. So we are already, deep into our technology and tech debt that we have right now. But we do talk about using Supabase Auth as an alternative for our in-house solution for authentication. We really want, to get rid of our current solution and outsource it to someone else. And Supabase Auth looks like a great fit, given the fact that we also love Postgres. So it makes sense. So hopefully in the, 1 month or so, we can start evaluating Supabase Auth. And obviously you will know about it because we will do it together.
Thor, I don't know if you're... Last night Thor dropped his phone because he was trying to make sure he caught his beer. So obviously that's happened again. But maybe we can hand over to Francesco. If you've got a real-time use case, or maybe you can describe through any of your current situation. Or maybe you can actually perhaps start by giving a brief intro and your tech stack. Yeah.
Now, okay. I have to remove the fonts. Can you hear me? I'm audible?
Yeah, we can hear you.
I thought you might have dropped your beer as well.
Yes, I'm kind of new in the Little Dev. I'm the new developer advocate, and I've been here for a couple of months. Today is the second. It has been 2 months, and really enjoying staying here. We also enjoyed this part of the open source part I think to share something today. And yes, for now, I don't have any use case for real-time updates, but maybe we can find a way to collaborate together. Maybe we can try to do something live, or we can collaborate on something. So for me, it's today I'm happy to just be a guest, because usually I'm the host basically everywhere. So yes, I've been listening, but no, for now I don't have any use case that I'm using. Probably in the future I'll try Supabase in some of my live streams, probably, because I always like to try new technologies. I like the team, I like the people. So yes, that's it for now on my side. And yes, thanks for inviting me.
This may be a little bit off topic, but have you ever hosted a Twitter space?
Yeah, yes, kind of a lot. Yeah, there was a time when I was doing many. Now I'm doing less, but just because I'm more active on live streams on Twitch and YouTube. So, but yes, usually I've done. I think I don't know many, but many. I can't count the number. So
Okay, we'll reach out to you for tips after this, because this is the first week we're doing it. We're trying to figure out the best mechanisms. We actually just learned yesterday how to share
yeah,
tweets up top.
yeah,
So if anyone actually has any questions, you can tweet at Rory. He is monitoring anything with hashtag Super Launch Week. And if you put a question on Twitter with that hashtag, then he'll pop it up to the top. As long as you are using mobile, I think you can see it up top, and we'll answer the question in real time. And in fact, here is one right now coming from. Hold on, let me open it up. We have coming from Docker containerized paradigm, and to use the chat example, would a new instance be spun up on a channel by channel basis, assuming 1,000 concurrent users? Yeah, so the way that it works is we've got an Alexa server, and if you don't know much about Alexa, its roots are in Erlang. The sort of mobile, it started with Ericsson, so good for phone cases. There's actually a framework that we use called Phoenix, which is built on Alexa, and they have a sort of a benchmark, which is quite famous from many years ago, where they scale a single server to 2 million concurrent WebSocket connections. So it's that framework and that same system that we use for our real-time server. We haven't actually benchmarked how many concurrent sessions we could hold at the moment, but in theory, it's kind of limitless because of the way that Erlang works. You can just spin up extra servers and they kind of communicate across. You can cluster them very easily. So the question was, would a new instance be spun up on channel by channel basis, assuming 1,000 concurrent connections? No, the way it works is that you have one server which attaches to your Postgres database. And in theory, this would sort of scale up by the server limitations. So, for example, you would say when we're getting to 80% RAM, we might spin up two servers and they were both attached to your database. So if you had, say, let's say one server could hold 1 million connections at once, then you have one single server attached to your database, and that handles that Elixir server handles the connections to the database. So that's quite nice because Postgres doesn't handle connections too well. So yeah, it really cleans that up. Sorry, you back, or should I take over?
No, all good. No beer's fault today. Somehow my headphones are acting up. There's something in the connection. Something's interfering with me, so I had to remove them. But yeah, brilliant. Maybe Paul, while you're speaking already, do you have a cool use case for real time?
Yeah, well, I mean, we're obviously chatting about this today, so I was asking a few people. There's quite a few, interesting ones. Of course, like maps is a big one. One that you can do very well with Postgres because of PostGIS, and so that's definitely an interesting one for Supabase. I'd love to see more mapping use cases. Of course, collaborative tools are becoming very popular these days with Figma and Notion. So anything to do with like multiple people connected to a single application, making sure updates are fresh all the time. These are good ones. Yeah. What else? Maybe, and I think what else did we chat about? Because
Yeah.
I've been coding all day, so I've
Well,
got coder's brain.
there was one. So my startup before Supabase was a cryptocurrency trading platform, and that is a use case where you absolutely need to have the most up to date information, like at all times. And it's I think I was hacking around at the time with polling, which obviously doesn't give you the most up to date information. And so I kind of wish I would have had Supabase and obviously the real time security that we now have when I was working on that project. But yeah, anything to do with that kind of like data that's changing by the millisecond, and you need to make fast decisions on when to buy and when to sell, is really crucial.
I think that's a good one as well to point out, because if the database itself is getting polled, let's say you have 1 million people trying to poll it every millisecond, then of course the performance, your database is taking the hit. Whereas in this case, because of the real-time server, it takes the hit on these connections. So that's the one where, yeah, really it shines a lot, and it really shows that the engineering behind or the way that we've designed Supabase Realtime really works for these use cases.
We've got another question here in the feed.
Lovely. Oh yeah, actually, I might pick that up if I may. How would Supabase fit into developing a creators marketplace or platform? Kind of like Fiverr. Yeah, maybe why I'm so excited about that question is I used to work at Stripe, and Stripe has kind of a connect products to actually build money movement for marketplaces. But what Stripe doesn't have is kind of the whole authentication for developers. And so really where Supabase fits in is kind of the whole authentication, database storage, features that you need to actually build your platform, may it be on the web, with your web front end, but as well, a mobile app if you're building that for your marketplace. So, have Airbnb, Grab, kind of all these marketplace use cases. And so specifically around authentication with marketplaces is very interesting, because you have different sort of types of users. So you have kind of the service providers, that of course have sort of different authentication requirements in terms of, okay, I'm a service provider, this is my account ID, this is how money is moved to my account from these customers, and then every user of course needs to be authenticated. And so yeah, actually we should probably build a template. So we have a great subscription sort of software as a service template that we've partnered on with the good folks at Vercel. So that's on their Vercel GitHub. You can go check that out. But we probably should extend that to kind of a marketplace template with all the Supabase features. Yeah, so maybe we can do another hackathon and get that going. Brilliant.
Actually, I have a question, if I may.
Oh yeah, go for it.
So you mentioned the performance of the real-time server, and then the latest trend right now in the infrastructure is all the edge computing news that we get. So I wonder if you have any 2 cents to share about this, and whether you have any plans implementing the real-time server on edge computing.
Yeah, I'll pick that one up because Edge is definitely one that we're thinking hard about. The database itself will have to be split up around basically on the different edge, and then the real-time instance will be co-located with the database. So it's definitely one that we'll think about, not just for real-time, but basically across the whole Supabase ecosystem. One of the most popular things that we hear often is when we're or we get asked is when we're going to bring out functions. A lot of the time, people are asking about functions is because they want them on the edge. They want to put business logic on the edge, and they don't want it to touch the database. So really, this is one that we're building up towards, but we're starting with what we think are the hardest things within the developer sphere right now. And there's a lot of problems that are kind of unsolved within the database space, whereas there are a lot of companies pouring into the edge space. So we feel like we're well placed to help out those who are underserved, whereas we love to partner with companies like Vercel and Netlify who are doing really great stuff on the edge itself. And we just aim to work very nicely with these.
Great. Does that answer your question, Nito?
Yeah, of course. Thank you very much.
Fabulous. And then I think we have one more question, not related to real-time really, but just are there any plans to implement a way to fetch multilingual content, possibly via Postgres.js? I guess there's different approaches.
This one I'm guessing maybe perhaps the question is on text search, full text search. I'm not too sure. What's your read on that, Thor?
Yeah, that's a good question. It might, because I think if you're just sort of wanting to pull different content based on, say, browser locale, that's not really a challenge, I think.
No, that one's doable.
Yeah.
But yeah, I mean, really, Postgres.js can pull any sort of information. But there is one within Postgres itself, which is sort of this amazing feature. When you start using Postgres, you really discover it's kind of got everything included. One of the things it has is text search. So if you wanted to use Postgres to build the next Google, well, you maybe not do that, but it will definitely do text search for you. So if you're storing a lot of your content, your blog inside it, you can actually do text search inside it. So to achieve text search with other languages is a little bit more tricky. And there are some extensions that you need to do for some languages. But we're looking into one, I think it's called PG Runga. And we'll look into this. It actually will cover all languages. We don't have to install a separate extension for different languages. It should cover basically any language because of the way it's implemented.
Fabulous. I think that is it with questions. We're also kind of approaching sort of the 1 hour that, it's a soft limit. But I think if anyone still had like a really cool use case that they wanted to talk about, do speak up now. Otherwise, I think we have a use case, which is hiring, which isn't really a real-time use case, but it's quite urgent always. So maybe, Ant, do you want to mention what we're hiring for?
Definitely. If you want to build Supabase Realtime alongside us, then now is a good opportunity to jump on board. Hiring for tons and tons of different roles. If you head to our and it's things like data engineers, auth engineers, Postgres people, technical writers, SREs, developer advocates, QA and test engineers, full stack engineers, all of the engineers basically. You should go and have a look. One of the cool things we do as well is we hire a lot of founders. Actually, I think most, probably more than half of the people on the team today have started companies or open source projects themselves in the past. So it's a really exciting team to work on. A lot of ex-CTOs, so good technical folk. We're fully remote. We currently have people across 12 different countries. We will try and hire from any country, and it's a very good place for people who feel a strong philosophical alignment, of course, to open source, because with everything we do, we try and make it as open and as free as possible with as little lock-in as is possible. So yeah, get your applications in. If you need some convincing of why it's a good opportunity, just feel free to hit me or Koppel or any of the team up on Twitter and ask your questions.
Or follow us on TikTok, because that's where you can see all the awesome office views that we have, at least in Singapore.
Definitely.
All right. And I think with that, we have reached the end. Thanks so much, Ido and Francesco, for joining us today and talking about your use cases there. And tomorrow, same time, same place. So on Twitter Spaces, we have a new player entering the game. Who might it be? So, if you're interested in finding out, 7 a.m. PT tomorrow on Twitter again, and we'll be continuing the chats there. All right, everyone, any last words? Otherwise, let's crack on with the day or the night, wherever you are.
Keep it real time. I'm so sorry.
That's terrible. And now no one's going to apply for a job. He's always like this, by the way.
Well,
thanks for dialing in, everyone.
Thanks, Emil. All right.
Yeah.
See us tomorrow.
Bye-bye.
Bye-bye.
Bye.